absent yesterday, the next 10 or 15 minutes we're going big brain. Okay, folks that were here, you have an advantage. You have an advantage because you were here yesterday. Are you ready?
Yes, sir.
All right. So yesterday was a nice review, like all the concepts we talked about involving area, right? We would talk about area bounded by the x-axis and a curve, or we'd look at the x, like area bounded by two different functions. And all the time, the key was to look at like this one little slice, right? There's nothing magic about this little black mark on the paper, but the idea was we'd look at the slice. And I would ask you questions like, how wide is the slice? And you guys would tell me.
Change in x.
Change in x, either dx or delta x, depending on, and if you wanted to figure out how long it was, top minus bottom. But sometimes we would look at like our slices going this way. And how thick is the slice if I'm slicing this way?
dy.
It's dy. And if I want to know how long the slice is,
Right minus left.
Right.
definitely not top minus bottom. If I'm slicing this way,
Right minus
it's right minus left, big minus small. When you draw the slice this way, dx, top minus bottom. When you draw the slice this way, dy, right minus left. And we're all good? Now what happened yesterday, for those of you that weren't here? Or for those of you that were here, what happened yesterday? What was the big new thing?
Sigma.
The idea was not to work with the flat anymore, not to work with area, but to instead, right, we would spin things. And so we had introduced this idea of like your axis of rotation. And so I take this region, and you guys are going to ooh and ah, I know, and you're going to spin it.
Ooh. Ah.
Well done. Wow, I can't pay for that stuff. All right, shut up. Man, now I got to edit that out. All right, so you get your axis of rotation. You're going to take this, and you're going to spin. And you're going to go from the flat to the three-dimensional. We're not going to talk about area anymore. Instead, we're going to talk about volume. But I still want you to think about the slice. For Edgar and Anthony, we were like really thinking about the slice, because if I take this little slice and I spin that slice, tell somebody near you what happens when you take the slice and spin it. What do you make?
A sphere.
Not a sphere. You take that little rectangular slice and you spin it, and what you get is
Cylinder.
cylinder. Good. All right.
My baby.
So let's take a gander at this problem, and you're going to want to have your calculator handy. Okay. So problems we're going to look at today. Do not do anything to my little sphere there. Okay. The problems are going to look like this. Region R is bounded by the function f of x equals 2 plus sine of x. The x-axis, the vertical lines x equals 0 and x equals 6. Set up, thank you, Nora. Set up the integral expression, which can be used to determine the volume of the object formed when region R is revolved around the x-axis. And for the sake of Edgar and Anthony and anybody else that yesterday just like wasn't quite the right day for you, let's just go through and do this. We've got our curve, f of x equals 2 plus sine of x. Okay, there it is, no big deal. I'm bounded by the line x equals 0. I'm bounded by the line x equals 6. Here's the region. Where's the axis of rotation? Where's the axis of rotation, Jennifer? How do you know that? Because I told you in the problem where the axis of rotation is. That just means I'm going to spin. I'm going to spin the region around the x-axis. This is what I'm going to call the axis of rotation. Some years I get really excited and I call it the axis of revolution. Everybody okay? Same thing? Exact same thing. Exact same thing. All right, so if I take this region and I spin around the axis of rotation, what's the visual? What do you get? Take this, spin it around the axis of rotation. You get a vase, you see it as a flower pot, you see it as Cinderella's dress, however it is that you see it. Now yesterday I had Geometry Sketchpad and we looked at this. I want to see what I can do as an art teacher, just in case this teaching gig doesn't work out for me. I want to give you guys a way to draw this. I am not great with the drawing, so humor me. This guy here is the original image. A way that you can better understand this is you reflect this region over the axis of rotation. So take this region and draw the reflection over the axis of rotation. So meaning, just take this, flip it. Don't let the OCD take control. This guy here is supposed to increase, then decrease, and get over here, so try doing that down here. But you've got to do the mirror image. It ought to look something like that. Are we okay? It does kind of look like the goldfish that I talked about yesterday. This guy up here is your image. This piece down here is the reflection of the image. Now you guys know I care a lot about this little slice. It doesn't have to be this slice. Let me draw the slice over here. As this slice gets spun around the x-axis, and if you were here yesterday, we looked at Geometry Sketchpad, right? That rectangle gets spun around the x-axis. Jose, what happens when that rectangle moves around the x-axis?
It creates a volume.
It creates something specific. Take a rectangle, spin a rectangle. What do you get?
Cylinder.
You get a cylinder, right? So this little slice, what winds up happening is you actually wind up, you take that rectangle and you're spinning it, and as you spin it, what you actually get is going to be a cylinder because you get a little bit of thickness here. The height here is the radius. The thickness here is what we're calling the height. You guys know the volume of a cylinder. You know the formula for that.
Pi r squared times height.
Right, depending on how you think about it, it's big B times the height, but it's really pi times r squared times the height. Big picture, we're still okay? Okay. Well, for this particular rectangle, when I take this rectangle and I spin it, the two questions I have to ask you are, how tall? How tall is that rectangle? Top minus bottom. The top is 2 plus sine of x. The bottom is the x-axis. How tall?
F of x minus 0.
It's f of x minus 0. Well said. So f of x minus 0 is just f of x. How thick?
Change it.
Change in x, so dx or delta x. So the volume that I'm really going to look at for a cylinder is going to be pi times the radius. What's the radius for this particular cylinder?
Changing it.
Not changing x. The radius is f of x. That gets squared times the thickness, which is dx. For the friends that were here yesterday, is everybody okay? Okay. Now I want to be careful. This pi times f of x squared dx isn't the answer. Why not? Why is that not the answer? I mean, why is that not going to be the final answer?
Because I'm not sure.
Okay. Ron Bear, why is it not going to be the final answer?
It's only one.
Right, that's the way that you find the volume for one little rectangle, one little cylinder. But what Riemann tells us to do is not find the volume for one little cylinder. David, what does he want us to do?
He wants us to take the different integral from 0 to 6.
Right, what Riemann tells us to do is you're going to take the volume, you're going to find the volume by doing a definite integral of this expression here, of the pi times the f of x squared times the dx from where to where? From 0 all the way to 6. So here's what I want you guys to do in the calculator. This should take like less than a minute. Go find that value. So we're doing the integral from 0 to 6. We've got pi. We've got sine of x plus 2, the whole thing squared dx. Just want to make sure everybody can get me the number value on their calculator. I really want you to just type this in one step. All my friends who are like, oh, I'm going to square it, then I'm going to find the antiderivative, then I'm going to plug in the 0 and the 6, then I'm going to multiply by pi. If you go into the calculator, one step. Abraham, do you have a number answer here?
I got 85.
You get 85, exactly 85?
85.744.
Yeah, I got 85.
85, want to give me some more?
7.7.
Wait, 85.7,
Were you radians or degrees?
744.
9.
Okay, how many of you guys honestly have 85.7449? Nice. So here's the thing. If I'm scoring this, most likely you're going to get 1 point over here. If I see your integral, that you've got the correct limits of integration, and you've got the pi. Does pi have to be in here?
Yeah, no. I'll
You
try
can
and
factor it out.
Right, it's a constant, so what's your other option?
put it up.
Is it degree or radian?
Radians.
Radians.
We're only ever in radian mode in calculus. Good question. I need to see the pi inside the integrand or outside the integral. It's a constant. That's okay. You're going to get another point for this guy over here, and then one more little point for getting the right number answer. This should be the kind of thing where the points rain down from the sky and everyone feels really good. For the most part, all the friends okay? We're ready for a push? Okay, here it comes. Try the next one. See what you can do. Before I erase this one, does anybody have any questions on this one? You can go calculator after. Yeah. Check out what?
They're doing like the same thing that I'm doing.
If your function is sin of x squared, it's supposed to be 2 plus sine of x. The 85.74.
Oh yeah, I didn't do those two.
I thought that we did when I look at it, but then when it's the time I know
The revolved around? Yeah.
Oh no, I had 2 plus sine of x.
No, it's just an extra.
So we don't multiply times negative.
I think that's where it rotates. Oh no, that's what I thought.
draw the
Did you multiply?
Just like,
Yeah.
Or literally like
You get 2 points.
put it down to the there. I don't think
It's revolved around anything that's
So we
so.
don't
It would
plug
be
it
like
in.
on it.
it's revolving around. I'll tell you, a picture is worth 1,000 words. The time that you spend sketching is time well spent. The time that I spend erasing this board is not time well spent.
like
There is definitely a challenge in problem number 2, and I don't think anyone's reading it carefully enough to see the challenge.
What's the challenge?
No, is it a negative? Is it a negative 3?
I remember when we did the shoe. I know.
How do you remember the y-axis
Is it? Oh, is it only when the graph equals negative 3?
What is it like?
No,
What are
right?
we doing with the negative 3?
then drop down.
But you know how we measure it? The reflection? I don't know.
D negative?
Yeah, like this, right? So then it's all the space right in the area. In between. Alright, so you drew that.
Oh, that's your other one,
So I'm not, if I could
right?
pull you guys together, I'm not seeing enough attention being paid to the axis of rotation.
Yes, so just drop it down to
Where is the axis of rotation?
Negative
Y equals -3. Not the x-axis, but this line down here is what you're revolving it around.
She's gonna be the square root of minus negative.
Like this?
square root of x minus.
For those of you that are struggling with the visual, sketch it. Let's do a little sketch. Right, so remember the way that you do that, you're going to start with your image, and then what? You're going to reflect it over the axis of rotation. So take the image, reflect it. Not over the x-axis, but the axis of rotation. So I would have to go, from the axis of rotation, I'm going to go up a little bit, then the curve, then down. So I'm doing a reflection, go down a little bit, the curve, go up. Don't let the OCD take control. That really is a message from me. This guy over here is your reflection. If you really want to get a better understanding, and we can thank Miss Blakely at East End for this, of what's going to happen, draw the rectangle. Draw your little slice. So like, here's my little slice right here. You could draw that slice anywhere you want to, but also draw the reflection of the slice down here. Right, Jasmine, I'm just drawing that slice so we can get a sense of the little rectangle and what happens.
Why aren't you going all the way down to y equals -2?
Because this guy here, it's the part bounded by the x-axis and the curve. That's the region that I'm interested in, not this part down here. So draw the rectangle and draw the reflection of the rectangle. Yeah.
So, you leave the space from 0 to -3 and then you leave it from -3 to -6?
Yes. Jennifer, can you say that one more time?
You're gonna leave the space from 0 to -3 and then from -3
You've got
to
this space over here from 0 to -3 that I'm not spinning. And when I do the reflection, that means I have it down here from -3 to -6 that I don't have an object. I'm taking this guy and I'm spinning that. And the difference between this one and the one that we just did is the difference between something being hollow and something being solid. Right? If I were to take this region over here and spin it around the x-axis, you get something hollow. And the hollow object that I'd want you to think about would be the new roll of toilet paper. The other one yesterday, we were
Can I
running
keep
low.
that?
No, it's mine. I need to bring this home.
Is that rubber band around here?
Yes, there's a rubber band around it so that the
That's
toilet paper doesn't go flying off the place. Everybody okay with the toilet paper? Okay. Toilet paper is a cylinder.
Yes.
True?
True.
The way we find the volume of a cylinder is pi r squared times h. Tell somebody near you, how would you find the volume of this toilet paper? Just the toilet paper? Just the toilet paper? Don't tell me, tell your neighbor.
Volume of the little one.
How would you find the volume of the toilet paper?
You find the radius of the hole. I mean, you find the area of the hole.
No, you find the
Jose, what would you do?
I was gonna say you just subtract the roll.
There's two cylinders. Right, you do like the volume for the big piece minus the volume for the small piece. Alright, so what I heard from Jose and I heard from lots of different folks is you find the volume like for the whole thing as though it was like solid and then subtract out the whole. We're okay? Alright, so let's try it. So let's think about that. The volume, if it was solid, you've got to go from the axis of rotation all the way out here. This guy here is what I'm going to call my big radius. Right, so imagine that this was a solid object. I go from the axis all the way out to the outside curve. You guys know the question I'm going to ask. How long is that? It's square root of x minus, because we were thinking top minus bottom. So square root of x minus -3, and of course you can really write that as the square root of x plus 3. But that's the radius if it was like a whole thing of toilet paper. And what you told me to do then is you had to like subtract out the hollow part. So what's the radius for this part?
0 minus 3.
It's going to be top minus bottom. The radius is 0 minus -3, which is +3. We're going to pull all of it together. The way that you find the volume if it was solid. So you take your big radius here, which is the square root of x plus 3 squared dx. I need limits of integration. Where are we going from?
0 to 9.
0 to 9. Is this okay?
Yes.
Okay, not the final answer. Minus
Pi.
pi,
Definite.
definite integral,
From 0 to 9.
0 to 9,
0 plus 3. 0 plus 3.
or just 3 squared
Yeah, 3 squared.
dx, right? So this is like, I like to think of this as like the big radius. And this guy over here is like your small radius. Okay, only thing left. Take a minute, give me the number answer. Okay, and Marvin and Rombier and Jonathan, I'm definitely interested in you guys getting this. I bet you're gonna get the same answer this time. Because we're not doing anything with trig functions.
Because it's pi r squared.
Yep.
Could you explain the square root of 3? I mean, square root of x plus 3 part?
So when you're determining the rectangle, the length of the rectangle, you do top minus bottom. So from square root of x
Square root
all
of
the way
x.
down to -3. So square root of x minus -3. Top minus bottom.
Are you saying you had it right? No, he said you got it right. 466.52. 65?
You can put d of x. You can put d of x. I got 466.
No, he said you had it right.
You square it?
I might just say it right.
You guys looks like
We all get the 466.526. Okay, we finally get to the
Only thing that's right.
You got it?
You can say it's
Alright, it's all good. There's enough people that have this as their answer. I'm convinced this has to be it. 466.526.
I know
You
you
got a
don't
different
get
answer.
how.
I'll come over and look at you guys in just a little bit. Okay, before, if I can put everybody back together. Before I completely leave this, I get so excited about big R and little r. I never actually finished the conversation about why do you draw the reflection down here. The reflection is to help you visualize the three-dimensional piece. Here's how you get the three-dimensional piece, and we can thank Ms. Blakely for this one. You get the rectangle up here, you get the rectangle down here. You're going to connect the inside parts of the rectangle with a little hoop, and the outside parts of the rectangle with a little hoop. The idea with like the little hoop is it kind of gives you the impression of the rotation, so it kind of looks a little three-dimensional. If doing the drawing doesn't help, don't waste the time on the drawing. Okay? But if you're interested in being able to like give it some three-dimensional quality, rectangle, rectangle, connect the inside pieces, connect the outside pieces, that gives you like the appearance of the three-dimensional revolving. All right, so with that said, we get about 25 minutes, and I want you guys to get some practice and grow the smarticle particles. So working at your table, see what you can do with model problem number 2. You're not going to read different answers, but not two. So two of you are agreeing on one person. Who would choose? Okay, but you shouldn't have to. So part of the issue here is you forget to square it. Yeah, so that's part of the problem. Okay, the other thing, I don't know that I would do any of the work over here. I would just do it all. Alright, let's see if I can just do one count here, one row. Square mix.
The only thing playing in my head right now is the friends thing. You know what without the joke.
I can't remember
I
anything.
didn't watch it yesterday.
I'm not worried about that.
I really like this pen.
Yeah, we
I like it too.
would say use the upper half of it.
Replace the cartridge, that's all you got to do. You can do it.
Okay, so now what I want
Because I use it a lot.
you to do
You think about all the way, moving on to the
It's good for you.
You must think ahead.
All right, looks like just about everybody is done with this one. Okay, I'm deliberately picking friendly graphs. We've got y equals x squared. We've got x equals 0. We've got x equals 3. Axis of rotation is the x-axis. Important question for you to keep in mind. Solid or hollow? Solid or hollow?
Solid.
Solid, right? This region completely touches the x-axis. Solids are your friend. Because the volume of any solid, it's going to be pi. We're going to do the integral from a point to a point, whatever your function is squared dx. And I saw in just about every single paper, pi, the integral from 0 to 3, x squared squared dx. Probably 1 point here, probably 1 point there. If it's a no calculator question, let's assume it's a no calculator question, I'd expect you to finish it off from here. So we've got pi, integral from 0 to 3, x squared squared, x to the 4th dx. No point for that. Your next move, what's the antiderivative of x to the 4th?
1 over 5 x.
Antiderivative of x to the 4th. It's been a while.
1 over 5.
Add 1, divide by the new power. So pi x to the 5th over 5. I want to see that vertical bar. I want to see integrating from 0 to 3. That probably gets you another point. Last thing, plug it in. Pi times 3 to the 5th over 5 minus pi times 0 to the 5th over 5. How much further do you have to go?
Not any further.
Depends.
Response.
Depends. Free response, please stop. Please stop. But let's assume it's the multiple choice. Okay. If it's the free response though, you can stop right here. If it's the multiple choice, there's some smart cleaning up that I can do. Some smart cleaning up that we could do. Jennifer, what could you do?
0 to the power of 5 is 0.
0 to the power of 5 is 0. Divided by 5 times pi? 0. Okay, pi times 3 to the 5th over 5. That's a great answer. I'll tell you though, it will not be one of the answers on the multiple choice. I know this is mean. I would expect you to figure out 3 to the 5th. So like, take 20 seconds. 3 to the 5th. Avoid saying 8 or 15. 3 to the 5th. 3 times 3 times 3 times 3 times 3. 243. 243, 5, 5.
I was still doing it.
Yes, I would 100% expect you to do that on the multiple choice. All right, now it's time for a challenge. See what you guys can do with problem number 3. Trust your smarticle particles. Definitely going to want to have some conversation with somebody near you on this one.
When you say square root of x, I think you mean x squared. So I didn't say anything. No, because I was like, what am I thinking about?
I thought you said square too. I thought you said square.
That's why
but
when
you
I saw
said
your
right.
paper, I was like,
Yep.
that's not a parabola, but you're right. You know what I mean?
Yeah, I thought you said square too. But I knew you said square root.
But how do we draw this? I don't do those. I don't know. But yeah, that's what I thought.
I thought that's
Yeah, this is
that is crazy because I thought they, but I was like, oh yeah, I just said this because I knew what he meant.
Thinking going on.
I literally thought, whoa, that's crazy.
Yeah, I'm like, that's so weird.
All right, so it looks like everybody's got the right region. They've got a good idea. The most important question for me to ask you right now is solid or hollow?
Solid.
That's pretty consistent, solid. What could be hard about this then? Because you know that the way that you find the volume of a solid, it's going to be pi, there's going to be an integral, you're going to go from a place to a place, you're going to have a function squared dx. What could possibly be worth our having a conversation about? What's the tricky thing? There's something tricky in this one.
It's a negative.
Curious, what's the visual? Spin this around the x-axis. What do you guys see?
Tornado
You're taking this guy here and you're spinning around the x-axis. What's the object? Okay, pyramid. Oh, like the tops? Half of a sphere. This part over here, but you're not counting to the triangle. Dreidels are a little boxier. It's a, Juan, one more time. It's a cone, like an ice cream cone. Or a snow cone. Okay? No, a snow cone. Like the cone and then the snow.
Watch the cube.
You got me? So here's the question. When I draw my little representative slice, I gotta tell you, the whole story happens in the slice. You guys know whenever, oh, I guess I'll be keeping that for you. Don't worry, I'll get you your chapstick. When I draw this slice, there's 2 questions I'm always gonna ask. First question? How tall? Second question? How wide? How tall? F of x, how wide? How wide? Delta x or the dx, depending on what you want to do. But what if I had drawn my rectangle here? Height is f of x, the width? Dx. What if I had drawn the rectangle?
X.
Now it's g of x, and the width is dx.
Oh, so you need to do.
You're gonna have to use two different integrals. Because from this point here to the intersection point, your rectangle, that rectangular slice, has one height. And after that, you've got another height. Jennifer, what's up?
What if you do the horizontal?
Oh my God, if I had a heart, I would weep or something. Such a smart cookie. We're not quite ready for that yet.
No?
The reason that we're going to consider the vertical slices, the slice is perpendicular to the axis of rotation. I'm spinning around the x-axis, my slices go up from here. So here's what I care about. Can you get me the integral expression?
See.
That's worth 3 points. Show me what you can get.
I don't know how to say it. Basically, you know, if I use the intersection, you just change the point. And like, just two different equations. So F
Right, that's why no terminology works so well. Because you can think, because one, you can think about like, there's the cone, and then there's like the snow.
I thought it was like just two separate integrals and then you together.
Yeah, I want to see the integral set up.
So it would just be
Basically, that what you
zero
do.
to whatever.
Yeah, and then I didn't know what
Let's call it from 0 to A. We need to use
Yeah, we just did this.
F of x.
Okay, so we didn't do it on the
F of
calculator.
x squared
Good, so finish up.
d of x plus A to, what's the other endpoint?
Yeah, but F of x squared is F of x is
Oh, I love all the right conversations are happening.
Squared.
Oh, no calculator.
No, no.
I have high expectations.
So how do I find the intersection?
Oh, great question. How do you find the intersection? All right, so from what I saw walking around, just about everybody has the right setup. They know it's going to be pi. You're going to have the integral. It's going to be the square root of x, the whole thing squared, dx, plus pi. There's going to be another integral, negative x plus 6, the whole thing squared, dx. Life is great, but the most important piece here,
The points of
what are the
integration.
limits of integration, right? Some of these are easy. Somebody give me an easy one. Easy one that you know for sure, Mariah?
Zero.
Zero.
Where? Where does the 0 go?
First one on the bottom.
Why?
Because you're starting with zero.
Because I'm starting over here at x equals 0. Anybody see any other easy ones? Easy ones. Adriana, easy one.
The 6 would be at the top of the second one?
Okay, this guy over here has a root at x equals 6, and that's where the second integral stops. Now I think we're out of the easy ones.
Yeah.
Maybe some divine inspiration and a friend whispers to you and tells you what the answer is. I saw Adriana, she made a table of values. She said, if I'm going to find this intersection point, let me plug in values for x into both and see if I'm getting the right answer. Another option,
Let them equal to each other.
right? To find the intersection point, I want to make sure you've got options. So to find the intersection point, I'm going to do this part fast. Right? Set them equal to each other. Your next move, square. Square root of x, the whole thing squared is x. If you say negative x plus 6, the whole thing squared is x squared plus 36. I'll throw my shoe at you.
X squared plus 36, yeah.
Right? You're really going to make this negative x plus 6 times negative x plus 6. You're going to box it out. If I want to solve this equation, get the x's on the same side. Factor. Marvin's really happy that the mental math skills were working well for him. If 0 equals x minus 4 times x minus 9, then x equals 4 or x equals 9. Which one?
4 equals 4. 4.
It has to be x equals 4. If this root over here is at x equals 6, and the intersection point happens before, it has to be 4. What happened with this x equals 9, and this is more of an algebra thing than a calculus thing, when you square both sides, sometimes you bring in solutions that aren't actually solutions. And the fancy word for this, so you can impress the friends when you go to college, it's called an extraneous solution.
Come on. We learned that.
Yes, you did, back in algebra. Make sure you get that copy down. Extraneous, not extraneous. Extraneous. Think about it, not extraneous. Extraneous. Okay. So the only thing I would have you guys do from here, if I wanted to spend the time, you'd integrate, you'd add, life would be good. Really, you're gonna find the bulk of the work is figuring out what does the region look like, what's the right approach, and then can you give me the setups? This is all the new stuff. And this is what you guys are gonna get practice with tonight and tomorrow night. We're good? All right, I think you guys are ready for a push. Yes.
So we would
have like
good.
2 minutes left.
It's called 6 minutes. Okay. Problem number 5. Enjoy the ride. I want to be a proud papa.
Oh
Be a proud
god.
papa.
Y-axis.
Mariah, you don't hate me, right? Okay, you hate yourself, okay?
I'm down about it. No calculator or calculator?
Let's go with no calculator. Let's go with high expectations, shall we?
I can get a gap when I drew them. Equal everything to y. I mean, equal everything to x.
Oh god.
So I'm a proud
yeah.
papa. Everybody's got the right region. But sad face, less than half of you are reading this question carefully enough.
Find the volume.
Where is the axis of rotation, Edgar?
The y-axis.
Y-axis.
The y-axis is your axis of rotation. Juan, what does that change? What happens there? Here's my y-axis.
So it'll be
How does that change your thinking?
x squared.
Think about the spinning. You're not really sure. No, Amy, what changes now? Right, you're not thinking about the reflection down here. The x-axis isn't your axis of rotation. You need to think about the reflection here. Again, don't let the OCD take control.
Oh, it's pretty.
Solid or hollow?
Solid.
It has
Solid or
a
hollow?
hollow point in the middle. There's a hollow point.
No, it's solid because
Solid.
don't touch
It
it.
it
says it on the
connects.
problem, it's it said the
okay,
volume
yes,
of the
thank-
solid form.
Thank you for the readers. The readers, yes, it mistakenly says the word solid. Look at the image though.
There's like a gap in the middle.
This hollow, there's a gap. There's a missing piece. Hollow. So not solid, hollow. David, what's your question? Okay. All right. Where's the rectangle that you drew? The little rectangle.
It's right there.
Wherever you
Oh, that is.
Which way?
Oh,
I
sorry.
mean, what? No.
If this is your axis of rotation, your rectangle
Got it.
is this guy. And its reflection is over here. And for those of you wanting to get a good visual, you connect the inner pieces with the little hoopty thing, and the outer pieces with the little hoopty thing. So what you're getting with your slice,
It's a Pokeball.
oh, I lost it. It's out there somewhere. Oh, it's in my pocket.
Oh, it's a Pokeball.
Kind of looks like this. A donut, or it's called a torus, or you call it a washer.
A bagel.
Right, or it looks like a bagel. For those of us that live in Meyerland, yes, it's all about the bagels. Okay? But what you're getting, right, stay with me. Right, is everybody okay with the washer?
Yes.
Donut, torus, whatever you want to call it, right? You've got the big piece, and then you get the small piece that you've got to subtract out. What makes this one tricky, though, is the orientation of the rectangle. 2 questions that I'm always going to ask about the rectangle. Like how tall, how wide. But if my rectangle is spinning this way, how wide is it? It's dy. How long is it?
It's
Right,
minus
right,
11.
I need right minus left, which means everything is now a dy. So you're going to do pi, something gets squared, dy, minus pi, something gets squared, dy. Okay, what function's on the right? See the one on the right that looks like y equals x squared? So solve that for x. Take the square root. X is going to be the square root of y. The inside guy, that's going to be y equals the square root of x. Solve that for x. You're going to square both sides. Y squared is equal to x. I want to know what big R is. Big R, you go from your axis all the way out to this curve. How long is big R? From here to the outside curve.
Y squared minus
Right? The outside curve is y equals x squared, but I've got to be careful. I've got to use this version. So I'm going to say it's the square root of y minus 0 squared. Then I've got to look at the small r, that's this inside guy here. And that goes from y squared minus 0, the whole thing gets squared. We're going to talk about this more tomorrow, right? I know we're going too fast, my apologies. Okay. Last thing to finish off would be to figure out your limits of integration. All my mental math folks hopefully know that that's the origin. And where would these guys intersect?
1.
If x equals 1, then y equals 1. So you're going to go from y equals 0 to y equals 1, and from y equals 0 to y equals 1. I know I totally went too fast there, my apologies. Problems 1 and 2 from tonight's homework, I don't think have anything to do with revolving around the y-axis. We're going to do some area work, we're going to do some revolving around the x-axis work, some hollow, some solid, and I'll see you guys in room 28 in about 9 minutes.
1 and 2?
Just 1 and 2, although if you want to get a